So now we are continuing just with short questions for this chapter. So how would you classify a coarse-grained igneous rock that contains 50% of pyroxene and 50% of olivine? So you can just use the diagram from before and then you can compare it and then we can figure it out. So next question is, what kind of rock would contain some plagioclase feldspar crystals which are about 5 mm long, and they are floating in a dark gray matrix of crystals which are less than 1 millimeter in size. So therefore you must know then that plagioclase crystals, especially anorthite plagioclases, they are showing a very low density. So and that means they are floating up in a dark gray melt, and the dark gray melt, that is a melt which is then more mafic in composition and that has then a higher density. So then the next short question is, what difference in crystal size might you expect to find between two silts? Yeah, your silts, you know, these are the dikes. One intruded in a depth of about 12 kilometers, where the country rock was very hot, and the other one at a depth of about 0.5 kilometers, which is very close to the surface, where the rock was, or the country rock was moderately warm. And now you should give an answer which rock shows large crystals and which rock has then more fine-grained crystals, formed in these different depths. So next questions, what I have here, we are assuming that the magma with a certain ratio of calcium and sodium starts to crystallize. Yeah. So then we have to think about which minerals we can expect which minerals we can form using calcium and sodium in a magma. There, for example, we can have the plagioclases. So, and these are maybe the minerals which will be formed. So, and if fractional crystallization occurs during the solidification process, that means we are making from our melt a solid, will the plagioclase feldspar formed after complete crystallization have the same ratio of sodium that characterized the magma? So, we know by now that plagioclase feldspars formed at high temperatures are more calcium rich, and those ones which are forming at lower temperatures are more sodium rich. So, and while we are crystallizing the plagioclase from our melt, we are removing always calcium at the beginning, and at lower temperatures we are removing then sodium, and therefore you should now give an explanation how the chemical composition of your bulk, that means of your melt, will change while you are removing, for example, the plagioclase during fractional crystallization. So why are plutons more likely than dikes to show the effects of fractional crystallization? So now you have to think about how a pluton is formed, how the dikes are formed, and where you can observe their effects of fractional crystallization. So, and now the next question is, what might be the origin of a rock composed almost entirely of olivine. So this question you should also be able to answer it just from our last year class, yes? And then you can easily find out which rock hosts most of olivine or hosts a lot of olivine. So then we have the next question: what processes create the unequal size of crystals in porphyries? Yeah, we have discussed this before, and I mean here the PowerPoint is related to the textbook Understanding Earth. So in the Understanding Earth textbook is a textbook which you can find in the library here at the UNAM library, and then you can just study it and investigate it. So now the second question what we have to answer is, how do magmas form? So we have here table 4.2, and there we have the factors affecting melting temperatures. So we have higher melting temperatures and lower melting temperatures, and the melting temperatures of the melting temperatures are also strongly correlated to the pressure, and the pressure is correlated to the depth. So if we are expecting higher melting temperatures, then these higher melting temperatures are related to higher pressures. So when we are looking at the water content, so when we the water content will increase or is higher when we have or when we are expecting lower melting temperatures, and at higher melting temperatures we are expecting a lower water concentration. So the rock composition, higher melting temperatures can be observed in more mafic rock compositions, whereas lower melting temperatures will be observed in more felsic rock compositions. So, and that is these are the reason why a rock melts. So we can make from a solid rock a molten rock, and we can make a solid rock out of a melt. Next question to be answered is, what is a magma chamber? So when we are looking at magma, we have a rising mass of magma that pushes aside crustal rocks as it rises through the crust, yeah? So when temperatures of about 1000 degrees Celsius are required for partial melting processes on crustal rocks. So we have a solid crustal rocks, and we need temperatures of about 1000 degrees that we can form first melt out of these solid crustal rocks, and that we are calling partial melting. So, and then we need at least a depth of about 40 kilometers and temperatures of about 1000 degrees for producing such a melt. Number 3, we will now talk a little bit about the magmatic differentiation. So, in the magmatic differentiation describes a process which rocks of varying composition can arise from a uniform parent magma. So we are dealing always with a parental magma, and from this parental magma we will subtract a melt, and this melt from the parental magma can have or having then another chemical composition as the parental magma. And the parental magma forms then the residual melt from this melt which we have removed. So the first minerals to crystallize from a cooling magma are the ones that are the last to melt. So that means if we have a magma and we are crystallizing the first minerals, then the minerals which we are crystallizing at first, these are the minerals formed at higher temperatures, because I mean at the beginning our melt has a higher temperature and then it cools down. So when at high temperatures we are crystallizing different minerals compared to those one which we are crystallizing at lower temperatures. So then the next point what we will have, that is fractional crystallization, is the process by which the crystals are formed in a cooling magma and are segregated from the remaining liquid, yeah? So if we are forming crystals during fractional crystallization, we are forming these crystals, and these crystals have a certain mineral chemical composition. And for example, if we are forming an olivine, then we are removing magnesium and iron from your parental melt, and this magnesium and iron and also nickel, yeah, is then sitting in the crystal lattice of your olivine, and therefore we are depleting your parental melt in magnesium and iron and nickel, because it goes then into your olivine, and your olivine will crystallize and will become removed from the melt. And that is then meant by fractional crystallization. We are dealing here with a continuous change in the mineral, in the chemistry, in the bulk chemistry of your melt. So, and an example therefore, that is the basaltic intrusion like the palisades in New Jersey. So, and there we have now a nice picture. Yes, we have the picture from the outcrop, and there you can see a lot of columnar basalts here, yeah. That is the basaltic intrusion there. Moment, where do I have the mouse? Here we have the basaltic intrusion. So here we have a cross section, and this basaltic intrusion is overlined by sandstones. Then we have here the basalt. So, and here we have the basaltic intrusion in the middle. We have here at the upper part a mostly sodium-rich plagioclase feldspar and no olivine. So, and if you have a sodium-rich feldspar, the sodium-rich feldspar is formed at lower temperatures, and at the lower part of the basaltic intrusion we have here a more calcium-rich feldspar, which is formed at higher temperatures. So we have here then a magma, or we have here an intrusion, but we are dealing with flotation. That means at the bottom of your intrusion we dealt with higher temperatures seen in the more plagioclase, more in the calcium-rich plagioclase feldspar, and at the top we are dealing then with lower crystallization temperatures seen in a more sodium-rich plagioclase feldspar. So, and at the bottom we have then olivines, yeah, and the olivines are actually formed even at higher temperatures. And below the olivine we have again the basalt, and there below we have a unit formed by sandstones. So that was it for the class today. I have subdivided these classes in two movies. That is GLY3632a and GLY3632b or 37, I don't know. You will find it then on YouTube, and then you can watch it. And tomorrow or on Sunday I will then just record the remaining stuff from the Engineers class, and then you can watch this as well. So, but meanwhile you can watch these two movies which I have uploaded, and then you can also answer the short questions.